Hello everyone. Today we are going to discuss the Internet Protocol version 10, the latest version of the Internet Protocol. Actually, when you first hear about the Internet Protocol version 10, it comes to your mind that there is a new address structure has been added to the Internet Protocol. Actually, it is not, because IPv10 is not like IPv4 and IPv6. IPv4 and IPv6 has address structure. IPv4 is 32 bits address and IPv6 is 128-bit address. IPv10 is a solution that will allow IPv4 only hosts to communicate with IPv6 only hosts and vice versa. That means that IPv10 adds the capability to allow IPv4 and IPv6 to coexist in the same network and communicate efficiently. Let's go to the next slide. For IPv4, you know that the address space is 4.3 billion public unique addresses. This IPv4 address space has been exhausted or depleted since the announcements that has been made by IANA and followed by the regional internet registries. When IANA announced it on 3rd of February 2011 and then followed by IPNIC in 2011, April 19th, and then RIPE NCC on September 14th, 2012, then followed by LACNIC. By the way, all those are the regional internet registries. For example, AFRINIC for Africa, ARIN for North America, RIPE NCC for Europe, LACNIC for Asia, for South America, IPNIC for Asia. 4 of the 5 regional internet registries announced the depletion after IANA, of course, and it is expected the announcements to be made by AFRINIC in 2018. This means that IPv4 is not existing anymore. Bye bye IPv4, it has been depleted. If you are going to ask for an IP address, you will be assigned IPv6 address. IPv6 was developed in 1995 by the IETF, and to use IPv6 on the internet you have to migrate from v4 to v6. This was the requirement. You have to migrate from v4 to v6 to overcome the problem of the depletion of the IPv4 address space. So this migration took more than 22 years, and until now no full migration occurred. This because of a lot of reasons. It comes to the enterprises, it comes to ISPs, they have their own reasoning not to migrate to IPv6. And by the way, it is worldwide, meaning that IPv4 still dominating on the internet traffic by more than 90%. Some recent adoption analysis shows that IPv4 domination is 80%. It doesn't matter, it's still dominating on the internet traffic, meaning that no migration has been accomplished. And the issue is that new internet clients will be assigned IPv6 only addresses. It means that we will have blocks of IPv4 hosts and blocks of IPv6 hosts. They have to coexist together and communicate to each other efficiently, because The migration will not be accomplished in 1 or 2 or 3 years. It will take more than many years. I cannot expect exactly how long it will take, but I can say that it will take decades, because it depends on enterprises and ISPs. Every enterprise, every ISP has to migrate to IPv6, so the internet will be IPv6 infrastructure. The recent situation is that we have IPv4 only hosts, IPv6 only hosts, and IPv4 IPv6 host. This is the dual stack. Most operating systems support the dual stack to have both configuration of IPv4 and IPv6, and in my opinion this is the best recent solution. Not the best recent solution, but one of the best recent solutions to use to allow IPv6 and IPv4 to coexist. But there is a problem, since the announcements that have been made by IANA and the regional internet registries is that there is no more IPv4 addresses. If you will ask for assigning an IP address, you will get only IPv6 address. Means if you want to use dual stack, you can use dual stack if you have an IPv4 address and ask for v6. This means you can use dual stack. But if you are a new customer or a new client to the internet, you will be assigned IPv6 only. There are no more IPv4 addresses. So you cannot use dual stack after the depletion of the IPv4 address space. When using dual stack, these hosts can communicate using v4 with IPv4 only hosts, and can communicate with IPv6 only hosts using v6. But between IPv4 only hosts and the IPv6 only hosts, there is no direct connectivity, and this will be explained by IPv10. As you can see, between IPv4 only host and an IPv6 only host, there is no direct connectivity. You cannot communicate between those two different hosts because they have two different versions, two different packet headers, and this is the issue. If you will not be able to use dual stack, there is no direct, and I mean direct, that there is no translation. There is no translations, because yes, you can allow IPv6 only hosts to communicate to IPv4 only hosts using some transitioning techniques that will be explained later in this presentation, but it requires so much translations, and some of them requires the involvement of the DNS64, as we will explain in this slide. Let's discuss the recent transitioning solutions. Actually, there are many transitioning solutions that allow IPv4 and IPv6 to coexist, but none of them allows IPv4 only hosts to communicate to IPv6 only hosts. The first transitioning solution is IPv4 IPv6 dual stack. It cannot be used, as we mentioned earlier, because new internet clients will be assigned only IPv6 address and they cannot have IPv4 addresses to have dual stack because IPv4 address space has been exhausted. The second solution is tunneling, and tunneling allows only IPv6 to IPv6 communication over an IPv4 network. It means that if you have two different sites and they are IPv6, they can communicate through an IPv4 network, but there is no connectivity between IPv4 and IPv6. It's only v6 to v6. The third transitioning solution is DNS64 NAT64, and it allows IPv6 only hosts to communicate with IPv4 only server using DNS64 and NAT64. But its problem is that it requires so much protocol translations. It requires statically configured bindings. It requires the involvement of the DNS64 in the communication process. And this is the complexity of this transitioning solution. But it allows IPv6 only hosts to communicate with IPv4 only server. The problem of the transitioning solution is that the dependence on internet clients. It means that you have to do some training for network admins, network engineers, ISPs to use the transitioning solution, to use dual stack, to use NAT64, DNS64, to use tunneling. So using translations, for example at NAT64, adds more complexity, and getting the DNS involved in the communication process adds more complexity as well. So it's not widely used. Not all enterprises uses this NAT64, DNS64. So we are going to discuss the solution that we are explaining and presenting in this presentation. It's IPv10. As you can see, IPv10 allows direct communication between IPv4 only hosts and IPv6 only hosts without DNS, without protocol translation. This is the major property of IPv10. There is no involvement of the DNS. We don't use it anymore. There is no translations. There is direct connectivity between IPv6, IPv4 only hosts and IPv6 only hosts. But to do this, all the internet hosts must be IPv10 hosts. And this will be explained in the next slide. The packet itself, the layer 3 packet, can contain a mixture of two different versions in its header. The source can be IPv6, the destination can be IPv4, and the opposite, the source can be an IPv4 and the destination can be an IPv6. Let's see what this will make to the internet. If you have two different hosts and they want to communicate, one v4, one v6. Actually, it will be explained in the next slide. Yes. Let's see how IPv10 works. We have two different hosts. They are IPv10 hosts. One with IPv4 only address and the second with IPv6 only address. When IPv4 only host is trying to communicate to IPv6 only hosts, and it can encapsulate two different versions of the IP in the same layer 3 packet header. Let's see how the communication will be accomplished. The packet that will be sent by the IPv4 only host is an IPv10 packet. It contains both IPv4 and IPv6 in the same header. So the source will be IPv4. The destination will be IPv6. So when the host will send the packet, the IPv10 packet, to the router will examine the destination IP address. If it is an IPv6 address, it will examine its IPv6 routing table. If a matching entry will be found, it will route the packet through the IPv6 network to the IPv6 hosts, and vice versa. Let's see if the IPv6 hosts is trying to communicate to the IPv4 only host. The IPv6 only host will encapsulate the source address IPv6, the destination address IPv4, and send the IPv10 packet to the router, to the default gateway, because it will consider the destination as an IP address in a different subnet, so it have to send it to the default gateway, which is a router. The router will examine the destination IP address, which is an IPv4 address. So it will use the IPv4 routing table and find a matching entry. If a matching entry found, it will route the packet through the IPv4 network until reaching the IPv4 only hosts. So IPv4 and IPv6 routing must be enabled on all routers so they can forward the IPv10 packets. And this is how IPv10 works. It allows IPv4 only hosts to communicate with IPv6 only hosts and vice versa. Let's see how IPv10 works with the DNS. If you have an IPv4 only hosts, which is of course IPv10, because we said that all internet connected hosts must be IPv10. If the IPv4 only host is trying to communicate to the IPv6 only host using host name, so IPv4 only host PC1 want to communicate to PC2. I don't know the IP, so IPv4 PC1 will send a DNS query to the DNS server, because the DNS TCP/IP configuration are configured on the IPv4 only host. Hey, I need the IP address of PC2. The DNS will examine its database and find an entry for PC2, which is a host AAAA record, 4A's record, and then reply with a DNS reply to the query with the IPv6 address of PC2. Now PC1 knows the IP address, the IPv6 address of PC2, so it will encapsulate a packet head. It will encapsulate the layer 3 packet header using source IPv4 address, destination IPv6 address, and send the packet to the default gateway, and then the router will use its IPv6 routing table and route the packet through the IPv6 network. The vice versa can occur because PC2 is trying to communicate to PC1 using host names. So hey, it will ask the DNS, I need the IP address of PC1. The DNS will search for the record it has for PC1, and it will find a host A record. It will find a host A record for PC1, and the reply will be an IPv4 address. Now PC2 knows the IPv4 address of PC1, and it will encapsulate the layer 3 packet header, which is IPv10 packet, with source IPv6 address, destination IPv4 address, and send the packet to the default gateway, and the router will use its IPv4 routing table and route the packet through the IPv4 network until reaching IPv4 only host, which is PC1. The IPv10 packet header is the same as the IPv6 packet header. So what will be required in the communication between IPv4 and IPv6 only hosts is that the IPv4 header will be replaced by the IPv6 packet header. This is the major issue with IPv10. It is required that all internet hosts are IPv10 hosts, and this can be accomplished by all technology companies developing operating systems to let the IPv4 packet the same as IPv6 packet, and this will be called IPv10 packet header, because the source, which is 128 bits, can be an IPv6 or an IPv4, but all of you knows that IPv4 is only 32 bits. Let's go back to the previous yes, this slide. The 128 bit of the destination address in this example will have destination IPv4 address, which is 32 bits, the MAC address of the destination host, sorry, the MAC address of the source host, which is 48 bits, and the beginning of the header are 48-bit zeros, and these zeros to let the router understand that the destination is an IPv4 address. Expect that the last 32 bits of the destination address is an IPv4 address. The same in this packet. The source is an IPv4 address, which is 32-bit. The MAC address of the source as well is stored in the packet. The leading are zeros, 48-bit zeros, to let the router, when the router will found that the first 48 bits are zeros, it will understand that the source is an IPv4 address, not an IPv6 address. So it can understand the source IPv4 address and check its IPv4 routing table and route the packet normally. The fields of the packet header are the same as IPv6. The destination can be IPv6 or IPv4, and it's as well 128 bits. The version determines the type of the packet. If it is 0100, the packet is an IPv4 packet. What this means? It means that the source and destination addresses are IPv4 addresses. So the communication can be occurred between two IPv4 hosts. Number one. If the version is 0110, that means the packet is an IPv6 packet. Means that the source and destination addresses are IPv6 addresses. This will allow the communication between IPv6 hosts. If the version is 1010, it means that the packet is an IPv10 packet. That means that the source can be IPv6 and the destination can be IPv4, or the source can be IPv4 and the destination can be IPv6. This will allow the communication between IPv4 only hosts and IPv6 only hosts and vice versa. This is the old IPv4 header as we used before: the version, type of service, total length, and so on. Some of these headers, some of these fields are removed in the IPv6 header because they are almost useless. So the old packet of the IPv4 will be replaced by the new IPv4 header, which is like the IPv6 header, so they will be the same. What are the advantages of using IPv10? As you saw, there is no protocol translations required. There is no involvement of the DNS in the communication process. There is no dependence on internet clients. What this means? How to allow all internet hosts to understand IPv10 or to be IPv10 hosts. This can be accomplished by updating the software of the NIC cards to let the encapsulation of both versions in the same packet, which is IPv10 packet. This can be accomplished by all technology companies. So clients must accept the updates to be IPv10 hosts and be able to communicate between IPv4 and IPv6. So there is no more dependence on internet clients. There is no trainings required for them to use IPv10. All what they have to do is to accept the updates, and then once all internet hosts are IPv10 hosts, the communication can be accomplished easily. No rush for the IPv6 full migration process, because they are already can communicate to each other, IPv4 and IPv6. And during the migration, there is no rush, because IPv6 can communicate to IPv4 and vice versa, and the migration can take its process smoothly without rush. Short time deployment process. To deploy IPv10 for all internet connected hosts, it can take, I can say, months or less, because it's simple updates that will be deployed to operating systems and to routers operating systems. It's an issue of updating the way of how the layer 3 works, just to encapsulate both different versions on the same header, and to allow hosts to react when they have a destination address different than its own IP version. It means that when a host finds out that the destination is from a different version, it will react as it is another IP from a different subnet and will send the packet to the default gateway. The default gateway or the router must understand that the packet can contain a mixture of IP versions from two different versions. It means that it can understand the packet have source IPv4 and destination IPv6 and vice versa, and based on the destination it can use its routing table and route the packet. Effective and flexible communication between IPv4 and IPv6 hosts, because as you saw, when using the encapsulation of both versions in the same header allows the for communication between the different hosts. It allows 4 to 4, 6 to 4, 4 to 6, 4 to 4. And this is the last slide, and of course if you have any questions you can drop in the comment area and it will be our pleasure to answer all your questions. Thanks for watching.